Hey there folks, Mr. B here. We're going to move on to chapter 6, and this is all about representing patterns as equations. Now, because we've done so much equation work, you should be pretty familiar with equations, x's and y's, and we've done a considerable amount of graphing as well. So, the equation that you should know best at this point is the linear equation. So you want to recall that linear equations, or straight lines, always take the form y is equal to something known as our coefficient multiplied by our horizontal value, and then you do a little addition or subtraction with a constant number. We saw a lot of versions of this, so I'll just write a few. Y is equal to 2x plus 3. Y is equal to negative 1/2 of x minus 4. Y is equal to 4x. Now, interestingly enough, you wouldn't write it, but I will put it in just to prove that it's there, plus 0. So I wanted to focus in on this. See this part here. This is why it's plus or minus. Now, when you go to graph these, this one's fairly steep. It goes on a graph, it'll go upwards like this. This one will have a negative slope, unlike the other one above it. And this would be very steep. And the plus 0 is quite an interesting thing to mention. This here, this little value right here, is where the y-axis is crossed. And that becomes a really big deal in grade 10. Y-axis intercept point. So more or less, if you cross, let's say if we're looking at this graph here, if it's really steep and you cross at, you pierce at 0, if this is your y-axis, this is 0 for y right here. So you crossed right where it said, at y is equal to 0. We'll get into that more next year. I'm going to move on to the next slide. So the formula we appear to have is y is equal to 3x minus 2. So triple the row number. Here's a good one. This says describe the pattern of beads. There's a regular sort of pattern of beads here. And come up with a formula. What do you have to multiply by? And what little addition or subtraction would you have to do to predict what you see below? So we're going to look at the row. That's probably why I've been saying row so much, because I knew this was coming. We're going to look at the row compared to the number of beads. We've got 4 rows. And we'll do a comparison like this. Number of beads in the first row is 5. Second row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Third row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you can pretty well see what's going on here. How many beads, you can see how many beads are increasing. It's going up by about 7 each time. 5 to 12. I should be saying, I miscounted the beads. There we go. Thought something was wrong. 7 in the first row. Going to 12. Going to 17. And in our last row, it should be 22. appears to be going up by 5 each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There we go. So, that's how many beads are in each of the rows. So in the first row we had 7, second we had 12, third we had 17, and the fourth we had 22. So remember in your table what you're really comparing, what they're after, is what's the equation? Like you could actually graph this. There's a relationship between the row number and how many beads there are. And that's what's being drawn here. I'll just draw the table side by side so maybe you'll see what the thinking is. X and Y can be a lot of different things. In this case, it's just the row number compared to the number of beads. But it could be temperature relative to altitude and lots of things we'd investigate in science. So the question is, what is the formula? What do we have to multiply X by? And then what do we have to adjust it by to make sure that we've got this pattern? Okay, so what I'll do is I'll move on to the next slide. Just go. Let's see here. There we go. And I just have to quickly recreate that table because it didn't come with us. 1, 2, 3, and 4. And our number of beads was 7, 12, 15, 22. So what might the formula be? Plus or minus C, depending on what we have to do. Now, when I look at the first row, I could think of multiplying by 6. So when I try out my first one, I tend to pick a number that's pretty close. I'll try around 6 and sort of get a sense of where I'm at. 1, if I multiplied by 6, I'd have to add by 1 to get 7. Now, if I went to my second row, would that work out? 2 multiplied by 6, I have to follow the same pattern. I can't change it. Plus 1, that's 13. It's not going to work. At this part, it falls apart. Grab my eraser and say, well, what if I try something a little bit different? What if I go and try something like, instead of multiplying by 6, let's try multiplying by 5. Let's a little bit more erasing work to do here. And what are my adjustments going to be? Well, if I multiply by 5, then I have to add 2 to get 7. Okay. If I multiply by 5, I add by 2, and I get 12. Well, the 7 worked out, and now the 12 worked out. So we're just multiplying the row by a given value, and then what we've got to do is we've got to get the correct number of beads. So in the third row, we've decided it's the third row multiplied by 5, adding 2. Does that work? 17. Okay, so 15. We take a look, say we got it. And in fact, we do. That's interesting. What happens when you do math and you're tired. That number is supposed to be 17. So, interestingly enough, looking back, I knew this point had to be wrong because after the first 2 points start to work, the pattern generally is set up. So, 4 times 5 plus 2 equals 22. We're good. So I just had to keep my eye on things there. There we are. We're good. So we have our formula. Changing color just to make this point. If the generic formula, or the general one, then what we have, this is what it could be. This, by the way, some students get mixed up by this. This just means you could have the plus version, or you could have the minus version. Looking at this, as soon as I see it, the number of beads is equal to 5 times, 5 times the row and then just increase by 2. So 5 times the row plus 2. And that can be pretty darn useful, because if this is your formula that you've now discovered, I could say, okay, fine, go on to the 1000th row. Put a little line here. So how many beads in the 1000th row? Well, here's the number of beads. 5 times 1000 plus 2. So your number of beads would have been 5,002. And you say, okay, I've got it. No problem. I figured it out. One last example, and should be cemented. Because I'm recording this, I have time for. Predict the number of, not white tiles, rather, sorry, I would like the number of green tiles. And this is based on the figure number. And you will see this again and again and again. The figure number turns out to be quite important. Here's a hint. The figure number will be your x. So I'll just write those there. Figure number and your number of your green tiles. So figure number, let's switch up here. Go with a brown, that'll work. Figure number 1, 2, and 3. Now this one's a little shorter. So the number of green tiles, 1, 2, 3, 4, 5, 6, 7, and 8. Done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like it increased by 4. Let's see if that holds up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did it go up by 4? 13, 14, 15, and 16. Okay. So the formula we're after is, what do you have to multiply by x, and what would you have to adjust it by to get the number of green tiles? So the green tiles is y, and your figure is x. So multiply your figure by something and add and subtract, and you'll know how many green tiles you have. Of course, we'd ask the question, how many tiles in the 4,000th figure or something like that. Once you know the formula, you can get it pretty easy. So here we go. We do little trials, and we say, well, what do we have to do to our figure to get our number of green tiles? Now, you might be tempted to start with a high number. As I look at these, I say, be careful. Start with somewhere around low. You can even start at 1 and work your way up. In the first case, it'd be 1 times 1. You'd have to add 7, and you'd see that wouldn't hold up. You make kind of an estimation of what you would want to multiply by first. Start with a low number, and then work your way up. So I'm going to start with something like somewhere around 4. So let's say, take whatever the figure number is, multiply it by 4, and to get this I'd have to add 4. Okay? Is that going to hold up? So take the figure number, second figure, multiply it by 4, and say, does this work? 8 plus 4 equals 12. See, sometimes you can get pretty lucky with these. You get them right off the bat. Because you first want to work, because you set it up and you say, this is my estimate of what it would be. Multiply by 4, and then add 4. There's your multiply guess, and then there's your add or subtract guess. And we see that this pattern holds up for 3 points. At this point, because you figured out your multiply and your add, this is like your K, and this is like your C. In other words, Y, well, actually let's use a slightly different color so that this is clear. That'll be good. Y is equal to 4 times your row number, and then you have to increase the quadruple of your row number by 4. And that is your formula. Nailed it. Now you might have started by tripling, and you'll see that didn't work out, and then you just move up. After tripling, if your formula doesn't work, try quadrupling. But you have to come up with a version of what you're going to try. In this case, it was multiply by 4, and then in order to even get the first one to work, I had to add by 4. So that was my pattern. Multiply by 4, okay, then I'm adding by 4. It works. As long as you multiply by 4 and add 4, this is good. So of course, here it comes. What would be the number of green tiles? Green tiles in the 400th figure. So you go back to your formula essentially. Okay. Y is equal to 4x plus 4. And you say, okay, 400th figure. That's the figure. And that's the number of green tiles that you're going to get. So based on the formula, the number of green tiles that we would get would be 4 times the 400th figure increased by our adjuster, by 4. 1600 plus 4. Well, there should be 1604 green tiles in the 400th figure. And there we go. So once you've got this done, managed to write these notes down, you can look at how the solution was done. This is neat because you get to do a little bit of guess and check, but the pattern that I've given you tonight is once you get a formula in mind, like this, then you've got to take it out for a test run and make sure that it describes the relationship between your x and your y variables. And as I've said before in class and several times, you're going to be doing this quite a bit moving forward into grade 10 and grade 11. So your assignment is in your book, and I put it on the board, but you really just need to go from question number 4 and move on to a new slide. Okay, so your assignment would be page 217, and you go from question number 4, and I want you to do, well, if you're feeling really hardy, you could do all of them, but you could do 4 to 14, and you have to do all of the evens in the assignment. And that means that you do every even-numbered question and all the parts inside the question. Okay, that's it. Good evening, good morning, and good night.